Hello students, nice to see you again in Mathematics Lovers Club. Today we are going to discuss a problem on equations of motion. So Vicky, now you read the problem carefully and tell me how will you do the first part of the problem. Yes, sir. I will first read the problem and mark the important words from the problem. So a particle is moving with constant acceleration in a straight line. It passes through 3 points A, B, and C with a speed 20 meter per second, 30 meter per second, and 45 meter per second respectively. The time taken to move from A to B is t1 seconds, and the time taken to move from B to C is t2 seconds. So you have to show that t1 upon t2 is 2 upon 3, and find also that the given also that the total time taken for the particles to move from A to C is 50 seconds. Find the distance between A and B. So now I will start with the first part. Yes, Vicky, but before starting with the first part, can you tell me which is the key word of this problem? Yes, sir. The key word here is constant acceleration and straight line. Now, because the acceleration is constant throughout the motion, we can use the SUVAT equations, and because the particle is moving in a straight line, that is the direction is not changing, that means speed and velocity will be taken in a similar sense. Very nice, Vicky. So now make a rough sketch for this problem and write the data for part A. Yes, sir. So suppose this is the straight path. On this path, there are 3 points A, B, and C. Now, when the particle is at A, the speed of the particle is 20 meter per second. At B, the speed of the particle is 30 meter per second. And at C, the speed of the particle is 45 meter per second. So this is a rough sketch to describe the situation in the problem. And now I will write the data. So first for the journey from A to B. So from A to B, the initial velocity u is 20 meter per second. Final velocity, that is the velocity at B, is 30 meter per second. And time taken t is t1. Now, since acceleration is the rate of change of velocity, that is, change of velocity divided by time. So acceleration is v minus u divided by t, which is 30 minus 20 divided by t1, or that is 10 divided by t1. Now, similarly, for the journey from B to C, the initial velocity here will be 30, that is the velocity at B, 30 meter per second. The final velocity, that is the velocity at C, is 45 meter per second. And time for this journey, t is equal to t2. Now, since the acceleration is constant throughout the journey, that means the acceleration is same for the particle when it is traveling from B to C. So again, I can say A is equal to V minus U divided by T, which is 45 minus 30 divided by T2, and that is 15 divided by T2. Now I'll equate this to, so that means 10 divided by T1 will be equal to 15 divided by T2. And that will give me T1 divided by T2 is 10 upon 15. Or that is 2 upon 3. And that is the thing we wanted to prove. Sir, is this particular part correct? Please let me know. Yes, Vicky. Very well done. Now, Mini, you come on the board and tell me how will you do the second part of this problem. Yes, sir. In the second part, it is given that the total time taken for the journey is 50 seconds. That means T1 plus T2 is equal to 50. Now, already in the first part, we have shown that T1 upon T2 is 2 upon 3. So, T1, I can write it as 2 upon 3 times T2. And solving these two simultaneously, I get 2 upon 3 T2 plus T2 is equal to 50. So if I take T2 common, it will be 2 upon 3 plus 1 is equal to 50. So T2 into 5 upon 3 is equal to 50, which will give me T2 is equal to 30 seconds. It is 50 into 3 divided by 5, that is 30 seconds. But T1 plus T2 is 50. That means T1 will be 50 minus 30. That is 20 seconds. Here I am finding T1 because I want the distance between A and B. And the time taken to travel from A to B is T1. That means it takes 20 seconds to travel from A to B. Now, for the journey from A to B, we have U is equal to 20 meter per second, V is equal to 30 meter per second, and time T is 20 seconds, we just found. So I'll use the equation S is equal to ut plus half at square. So first, I will find out the acceleration, which is v minus u divided by t. That will give 30 minus 20 divided by 20, which is 1 upon 2 meter per second square. And then putting in the equation, we get S is equal to 20 into 20 plus half into half, acceleration is half, into t square, that is 20 square. So 400 plus 1 upon 4 into 400, and that is 500 meter. Is that correct, sir? You are correct, meaning I'm not saying you are wrong. But can you think of any other simpler way to do this same problem? Can anyone tell me what can be the easier way to do this? So, can I say that we can just use S is equal to the average velocity U plus V divided by 2 into T, average velocity into time, which gives 20 plus 30 divided by 2 into 20, which will give me 50 into 10, and that is 500 meter. So, sir, here there is no need of finding the acceleration directly by knowing the initial velocity, final velocity, and time. Using the average velocity into time formula, we can do this. Correct, Vicky? Very well done. Even meaning, we have done this very well, but only the thing, try to find out the easier way, shorter way, which will save the time to do the same problem. But obviously, your formula should be correct and the way should be logical. Okay. Yes, sir. I did not think of this. Thanks a lot, Vicky, for helping me out. Always welcome, Mini. Very well done, students. I'm happy that you are responding very well in the class. Keep it up. I'll see you shortly with some more problems in mechanics. By that time, enjoy the day.